just carry on the block by the ground N, and there's a weight of the block. I'll apply an external force. This external force. Though I applied force, and so still what happened? What is the state of block? It is at rest. I think this will be something, and this surface I'll call it as rough. So somebody should balance. There should be some other force that should be acting. No? What is the, though the external force is being applied, still what happened? What is the state of the block? It is at rest. So there should be some other force balancing this applied force. So what can be some other force? I'll introduce a force called as a friction. So where the friction, it will be like this. What is this friction? Force exerted by the ground on the block. And we know, according to the Newton's third law, action, reaction, equal and opposite, or the force will always occur in pair. So there'll be also force by the block on the earth or on the ground. So what is this F? These two F's are very important here. So what is this? Force.
Sir, we can't listen your voice.
You are unable to hear me. Huh?
No, sir, it's clear.
No, sir, we can hear you.
Very low
We
voice.
can hear you, sir.
Now, can you hear me?
Yes, sir.
Yes, sir.
I'll check once. Wait. Can you hear me?
Yes, sir. Yes, sir.
Yeah, okay, I'll carry on. So what is this? Force by ground on block. So similar, this is by block on the ground. Okay, fine. That's the basic condition. I'm putting like this. So what is this? I'll call this F as friction. I'll give a name. This particular force, I'll call it as the frictional force. So what are the basic properties of that? And here, this particular frictional force, I'll call this as static friction. Any reason for that? Because there is no relative motion between the surfaces. So this will be static friction, we'll call it. Okay, now sir, what is the nature of it? So let's go for the nature of the friction. The first one, it's electromagnetic in nature. It is electromagnetic in nature. What do you mean by electromagnetic in nature? The molecules which are present here, see, friction will not act here. Actually, at every point, the resultant we are showing here, the molecules which are present here of the block and the molecules which are present on the ground, that one, they will interact. And that interaction, molecular force is what? Electromagnetic in nature. Because of that, what happens? This friction will come into picture. And what is the direction of it? It always acts to oppose relative motion between the surfaces. It always acts in a direction to oppose relative motion between the surfaces. This is the one basic property. How do I get the direction of friction? Now see, because of applied force F, because of actional force F. So what is the tendency of block? It will try to move towards right, no? It is having a tendency to shift towards right. So therefore the ground will oppose. So therefore, in what action the ground will exert force on the block towards left. Getting this? So there's a one, the whole chapter just revolves around this second point, what I'm stressing here. Then it's electromagnetic in nature. It always acts in direction to oppose relative motion. Then will it, this static friction depends on what? It is independent of the normal reaction. So here it's independent of weight, whether you keep a heavier block or lighter block. It is independent of normal reaction, and it is directly, or it depends on applied force. Okay, there is one basic conditions is what I'm putting here. It depends on the applied force. Then here, so means now I'll keep on increase applied force. I'll keep on increase the applied force. So for all the values of the applied force, the block will be attached. No, certain particular value, what will happen? The block starts shifting. The block starts shifting. So when the block starts shifting means now there's a relative motion between the surfaces. Then also when the molecules will interact, but the interaction will be a little bit weak or will be less compared to the interaction when the block is attached. So then also there'll be a friction acting. That will call it as a kinetic friction.
Sir,
Yeah. Yes, somebody?
yes, sir. Friction does depend on the normal reaction, right? At least the static friction.
It doesn't depend on normal reaction. Only limiting friction depends on normal reaction.
Yes, sir. That is the static maximum static friction, right?
That later on I'll make correction. Later on I'll make correction. Because in the interaction part I had to put like this. If it depends on normal reaction means then some very the question students will ask. Since you studied in school, okay. But first time, the way I teach only, I think that will be safer side. Okay, this will be now what is the state of block? Block will be accelerating. So what is the state of block? Block is moving. Now, is there any relative motion between the surfaces? Yes, it is. And the normal contact by the block on the ground. This is the basic idea. Now, this is called like a kinetic friction. So now let's focus on the something on kinetic friction. Kinetic friction. So this kinetic friction, I'll put it. So it depends on, we know n minus mg equals 0, and the kinetic friction depends on normal contact. Fine. So what is the nature that one? Similar to like what we had. Similar to static friction. It is also electromagnetic in nature. The kinetic friction also. Mu n, mg is this one. I'll write it. Okay, here kinetic friction is equal to somebody mute it.
All are muted.
This I'll explain. This is called as coefficient of kinetic friction. Mu k n it is. This will be where n minus mg equal to 0. I'll define one by one. It is electromagnetic in nature again. Kinetic friction. Electromagnetic in nature. It always acts in a direction to oppose relative motion between the surfaces. It depends on normal reaction, and it is independent of applied force. It is independent of applied force. Okay, what is mu k? Mu k is called as coefficient of kinetic friction. For different pair of surfaces, the value will be different. There's a symbol mu symbol, mu, not m. It is. This is m or m. It is like this. Okay, fine. Coefficient of kinetic friction, I'll call that one. So now, what is coefficient of kinetic friction? For different pair of surfaces, it will be different. For different pair of surfaces, the value will be different. The value of mu is different, and it is independent of, area of contact. This is one very, very important thing. Means now, there's about the basic ideas. Like the kinetic friction, what happens, there's a formula. So mu is what happens. It's a very difficult parameter to calculate. So a lot of, even till date, we can't measure that exactly, to be frank. Even till date, it is not being measured exactly. An approximate value is what we are able to guess by various experiments. That one. Find this one. See, we can find out experimentally by finding out applied force, then I'll find out acceleration, then I'll get Fk, and then. But direct measurement of mu k is what really problematic. That measurement of mu k is, even till date, we don't have suitable equipments to measure that. So what are the parameters, like what is mu k? For different pair of surface, it will be different. Pair of surface means what actually? You take now wood and the glass, they will have one value of mu. The same wood and rubber will have other value of mu. So for one surface, you can't say mu. Mu for a wood, no. Mu for wood and the glass, wood and rubber. So you can't say the mu for wood is this much. So with respect to what, the value of mu. So for a pair of surface, it will be different. So wood and glass, one value will be there. Wood and rubber, one value will be there. Because this particular, the friction depends on, friction is due to what? Interaction between molecules at the two surfaces. No? So when nature of surface changes, then the nature of molecules will change, the interaction will change, definitely the friction should change. So therefore the mu will be different for different pair of surface, not for different object, it will be different. It will be wrong idea totally. So most of the surfaces, we take it to be ground. Nowadays, I think the ground also changed. The ground, it can be granite, it can be marble, it can be floor, wooden floor. Got the idea? So there's about the basic thing, what we have. So there's about the theoretical introduction I give. So let me go for some directly the one example I'll take, so that it will help you a lot to understand this particular question, or this particular data. So let me take a block of mass, let it be 3 kg. It is kept on a surface, a rough surface. I'll apply a horizontal force, which will vary with the time like this. The normal